A convoy of heavy trucks rumbles along sun-scorched roads, shimmering in the intense African heat, transporting the massive components of the O&K RH 200E excavator. Starting from Richards Bay on the Indian Ocean, the convoy journeys inland, crossing through vast stretches of rugged African bush. Their destination is a sprawling platinum mine where preparations are underway. Here, on a 40 by 70 meter flat assembly area, 5 mechanics and 2 assistants are ready to begin the complex task of assembling the 500-ton hydraulic giant over the next several days. Once the slew ring has been secured to the undercarriage, attention turns to assembling the excavator's robust undercarriage structure, beginning with the connection of to one of the 2 massive track carriers. This central section serves as the core foundation on which the excavator will eventually rotate and move. Precise alignment is crucial to ensure a stable and secure connection between the 2 components, as they will later bear the tremendous load of the entire upper structure during operation. Bolts are first inserted and tightened by hand to ensure all parts are properly seated without cross-threading. Then, using a hydraulic torque wrench, the screws are fastened to the exact torque values specified by the manufacturer. This is vital to maintain the structural integrity of the undercarriage under extreme conditions. Each bolt must meet the exact torque requirement to prevent any imbalance or loosening during operation. Once the first track carrier is installed, the middle section is elevated, using heavy-duty supports. These supports are strategically placed to hold the weight securely while still allowing clearance beneath for mounting the second track carrier. Now, the 35-ton second track carrier is brought into position. Guided by skilled operators and suspended from a crane, the enormous unit is slowly maneuvered beneath the raised central structure. Precision down to the millimeter is required during this process to ensure perfect alignment. As with the first track carrier, bolts are then tightened using a hydraulic wrench to guarantee a rigid and safe connection. To finalize the undercarriage assembly, a bulldozer assists in joining the 2 track systems. Each individual track pad weighs nearly a ton and must be aligned and joined meticulously to complete the continuous track system. The slew ring gearing is thoroughly lubricated with high-performance, heavy-duty grease to ensure smooth rotation and durability. A strong adhesive is then evenly applied across the contact surfaces for secure bonding. With the slew ring gearing fully prepared and lubricated, a second 100-ton crane is brought in to assist with the most delicate and crucial lift so far. Under the precise guidance of a single, highly experienced marshaller, the 2 cranes operate in perfect synchronization to hoist the massive frame of the superstructure. This frame, forming the base of the upper body of the excavator, must be carefully aligned with the slew ring to ensure accurate placement. As the frame is gently lowered, a dowel pin is used to guide and fix it precisely onto the slew ring, helping align bolt holes and reduce any margin for error during final placement. Once seated, the crew begins tightening the connection bolts, first by hand to the engaging torque to seat them properly, then using hydraulic wrenches to apply the prescribed torque and retightening angle. Each bolt is marked to track the torquing process and ensure no steps are missed. With the superstructure frame securely mounted on the slew ring, the assembly team turns to the installation of the boom cylinders, critical hydraulic components responsible for controlling the movement of the excavator's boom. These large, heavy-duty cylinders are carefully maneuvered into place and aligned with their mounting points on the frame. Before insertion, each of the massive steel pins used to secure the cylinders is thoroughly sprayed with a high-performance lubricant. This not only facilitates smoother installation, but also ensures long-term protection against wear, corrosion, and friction during operation. Precision is vital, as improper alignment or dry insertion could damage the components or compromise the excavator's performance. Following the boom cylinder installation, attention shifts to one of the most substantial components, the 37-ton motor module. Once again, both cranes are deployed in tandem, operating under coordinated control to carefully lift and lower the motor into its designated position on the superstructure. The lift must be executed with extreme precision to avoid misalignment. Once in place, the motor module will serve as the powerhouse of the RH200, driving its critical mechanical and hydraulic systems. Following the installation of the motor module, the focus shifts to a task requiring the highest precision, alignment of the electric motor. This job is reserved for experienced specialists who employ advanced laser alignment equipment. With this technology, they ensure that the motor is positioned with tolerances as tight as 1/100th of a millimeter. Such fine calibration is essential to minimize vibration, maximize power transmission efficiency, and prevent premature wear of coupled components. Next in line is the installation of the cab module. This large, pre-assembled unit includes the operator's cabin as well as the integrated electric switchgear compartment that houses the control systems and circuitry. The module is carefully maneuvered into place, where it will serve as the nerve center of the machine, providing the operator with full control over the excavator's complex functions. Meanwhile, technicians prepare the 4 slew gearboxes, which are staged nearby in storage. These components will later engage with the slew ring to enable the entire upper structure to rotate with smooth, reliable motion. Before lifting the massive boom into place, the assembly crew mounts the stick cylinders and attaches the necessary hydraulic hoses, preparing the boom for full articulation. Weighing approximately 50 tons, the boom is delicately lifted using both cranes, operating in synchronized motion to prevent any tilting or stress on attachment points. Once aligned, a large wheel loader assists by driving in the enormous lubricant-coated boom foot pin, securing the boom to the frame. To complete the cylinder installation, a mobile platform is brought in, allowing technicians to work safely at elevation and connect the boom cylinders to their respective pivot points with precision and stability. The assembly continues with the careful installation of the 7.2-ton cooler module. Using one of the 2 cranes, this vital component, responsible for regulating the temperature of the hydraulic oil and engine coolant, is hoisted and gently maneuvered into its designated position on the superstructure. Once in place, it is securely bolted from the inside by technicians working in confined conditions, ensuring it is fastened to the frame to withstand the machine's immense vibrations and operating pressures. Following the cooler module, attention shifts to the largest and heaviest module of the entire RH200 assembly, the 60-ton counterweight. This component plays a crucial role in balancing the excavator's massive boom and bucket during operation. To handle such an immense load, both cranes are again brought into action, working in perfect synchronization. Slowly and steadily, the counterweight is lowered into position at the rear of the superstructure. Once aligned, a team of workers fastens it using high-strength bolts, which are torqued to specification using a torque multiplier to ensure uniform pressure and structural safety. With all the major mechanical components in place, the focus turns to operational safety. Railings, walkways, and bridges are installed around the upper structure to allow safe access for maintenance personnel. These structures are crucial for safe movement around the excavator when it's operational in the field. Finally, the superstructure is completed with auxiliary components, including a grease barrel, a tool cabinet, and a service crane. The grease barrel ensures constant lubrication for key joints. The tool cabinet stores essential maintenance gear, and the small service crane assists with future part handling. With these final additions, the superstructure assembly nears completion. The mobile platform is brought back into action to assist with the next critical phase, the mounting of the stick, the large arm segment that connects the boom to the bucket. This stage requires both precision and power. A wheel loader is once again used to drive in the massive, lubricant-sprayed pin that secures the stick to the boom. This operation is carefully guided to prevent misalignment, as the stick is a heavy and essential moving part of the excavator. The mobile working platform provides safe, elevated access for technicians as they mount the stick cylinders, large hydraulic actuators that control the movement of the stick and bucket. With the cylinders secured, the team prepares for another delicate task, installing the extra-large soundproof cab. Designed to house the operator in comfort and safety, the cab includes reinforced windows and insulated walls to reduce noise from the machine's powerful diesel engine and hydraulic systems. Great care is taken during this installation to avoid damaging sensitive components like the electric switchgear compartment built into the cab. In the days that follow, the focus shifts to integrating the hydraulic and electrical systems. Technicians methodically connect hydraulic hoses, control lines, and electrical wiring, referred to as the machine's lifelines. Grease and hydraulic oil are filled into the appropriate reservoirs, and every connection is checked for integrity. Electricians thoroughly test the circuits and control systems before the pivotal moment arrives. Monitored by the onboard control system, the engine is started up for the first time, marking the culmination of weeks of meticulous assembly. Meanwhile, at the mine site, preparations are underway for the deployment of the excavator. With 650,000 tons of rock ready for extraction, the final step is to mount the massive 25 cubic meter bottom dump bucket. A wheel loader again assists in pinning it securely to the stick. The 2 bucket cylinders are then installed, followed by the cable drum, which is mounted and connected at the undercarriage. At last, the RH200E, fully assembled and operational, is ready to begin its monumental task in the open pit mine. The Hitachi construction machinery Tsuchiura Works, located in Tsuchiura City, Ibaraki Prefecture, Japan, serves as the company's global mother factory for construction equipment. Established in 1974, it functions as a central hub for research, development, and manufacturing, particularly focusing on medium and large hydraulic excavators. The facility is instrumental in producing the renowned Zaxi series and has played a pivotal role in Hitachi's expansion into international markets. Notably, in November 2021, Tsuchiura Works shipped the first Hitachi-branded hydraulic excavator to the North American market, following the end of its joint venture with Deere & Company. Beyond manufacturing, Tsuchiura Works emphasizes environmental sustainability. The plant has implemented energy-saving measures, such as replacing compressors with high-efficiency models and achieving a waste recycling rate exceeding 99% as of fiscal year 2005. The arrival of the first CC880-1 crawler crane in Japan marked a significant milestone in the country's heavy lifting and construction industry. Manufactured by Demag, a German company with a rich heritage in crane engineering, the CC8800-1 was among the most powerful crawler cranes available when it debuted. Following Tadano Ltd's acquisition of the Demag mobile cranes business in 2019, the crane became part of the Tadano product line, symbolizing a fusion of German engineering excellence and Japanese innovation. The CC8800-1 made its entry into Japan in the early 2000s, purchased to meet the growing demands of large-scale infrastructure and energy projects. With a maximum lifting capacity of 1,600 metric tons, the crane was ideally suited for the construction of power plants, refineries, and major civil engineering undertakings. It became a crucial asset in lifting heavy reactor vessels, steam generators, and bridge sections that would be impossible for smaller machines to handle. One of the most impressive features of the CC8800-1 is its modular design. The crane can be configured with various boom combinations, including the powerful boom booster kit that enhances lifting capacity by increasing the stiffness and height of the main boom. With a maximum boom length of over 200 meters, when combined with the boom booster and luffing jib, the CC8800-1 provides flexibility and power unmatched by many in its class. Upon arrival in Japan, the crane was deployed to a high-profile energy project, where its capabilities were immediately put to the test. The sheer size of the CC8800-1 required extensive logistical planning. Transporting it involved disassembling the crane into dozens of oversized components, which were then shipped and carefully reassembled on site. The crane's crawler tracks alone weigh over 60 tons each, underscoring the scale of the machine. Japanese engineers and operators received specialized training to operate and maintain the CC8800-1, emphasizing safety, precision, and efficiency. The crane's advanced control systems, including Demag's IC1 control interface, allowed operators to perform complex lifts with confidence. This combination of cutting-edge technology and human expertise ensured that the crane operated smoothly and reliably even under the most demanding conditions. The introduction of the CC8800-1 in Japan also set a new benchmark for crane operation standards in the region. It showcased the importance of having high-capacity cranes in readiness for disaster recovery, nuclear decommissioning, and offshore wind turbine installation, sectors that demand extraordinary lifting power. Following its initial deployment, the CC8800-1 remained active in several high-stakes projects across Japan, earning a reputation for reliability and performance. Under the Tadano brand, support for the crane continued through parts, upgrades, and service, ensuring its longevity in the field. The Liebherr LB 44 is the latest and most powerful development in Liebherr's renowned line of deep foundation equipment. Designed to handle demanding drilling tasks with remarkable efficiency, the LB44 pushes the boundaries of performance, versatility, and job site mobility. Its robust construction, innovative features, and impressive technical capabilities make it a standout solution for complex foundation projects around the world. Engineering and design at the core of the LB44 is Liebherr's engineering philosophy, combines strength and precision with innovation and practical usability. Despite its large size, the LB44 is surprisingly transportable. Liebherr's design team has ensured that the rig can be easily disassembled into transport-friendly components, minimizing logistics challenges and reducing downtime between job sites. This is particularly advantageous for contractors who frequently relocate heavy equipment across urban and remote construction zones. The LB44 is equipped with a powerful BAT rotary drive, which represents one of Liebherr's most advanced innovations. The BAT, short for Bore-Antrieb mit Torque, or drilling drive with torque, rotary drive is known for its high torque output, enabling the rig to perform deep and wide borehole drilling with ease. The system's energy-efficient design reduces fuel consumption while maximizing torque, making it a cost-effective and environmentally friendly option for deep foundation work. Performance and applications. With its high torque rotary head and strong Kelly bar capabilities, the LB44 excels in Kelly drilling, a classic and widely used method for creating board piles. Kelly drilling with the LB44 is particularly effective in hard soils and challenging ground conditions, where power and stability are essential. The rig's drive system allows it to reach significant drilling depths and diameters, making it suitable for high load-bearing foundations. In addition to Kelly drilling, the LB44 supports other foundation methods, including continuous flight auger (CFA) drilling. CFA is often used in projects where ground stability must be preserved during drilling, such as in loose or saturated soils. The LB44's capacity to seamlessly switch between these drilling methods increases its versatility on diverse construction projects, such as bridges, high-rise buildings, infrastructure developments, and offshore structures. Another notable feature is its advanced control system, which offers operators real-time data and machine feedback. The intuitive interface simplifies operation and allows for precise adjustments during drilling. Liebherr has integrated safety features and diagnostic tools into the system, enhancing operational safety and reducing the risk of equipment failure. Mobility and job site flexibility. One of the key advantages of the LB44 is its mobility and flexibility on construction sites. Despite its imposing presence, the rig is designed for fast setup and takedown. Its self-assembly system allows the rig to be assembled without the need for auxiliary cranes, which significantly reduces preparation time and costs. Its undercarriage is engineered to provide optimal stability and maneuverability on uneven terrain, making it suitable for tight or complex work sites. Sustainability and efficiency. Efficiency and sustainability are increasingly important in the construction industry, and the LB44 addresses both. The BAT rotary drive consumes less energy while delivering more torque, and the rig's overall hydraulic system is designed for minimal energy loss. These efficiencies lead to lower fuel usage and reduced emissions. Liebherr also offers compatibility with alternative fuels and hybrid solutions for environmentally conscious operators. At Vestbase, a critical and complex heavy lift operation was successfully carried out by Sarens AS, involving the lifting and relocation of massive reels, using a Terex Demag CC2500-1 crawler crane. This operation was a part of a broader logistical effort that also included site movement via SPMTs, self-propelled modular transporters, showcasing Sarens' expertise in heavy lifting and engineered transport solutions. The Terex Demag CC2500-1 used for this operation was deployed in SSL configuration, superlift with a single-line main boom, and equipped with a 48-meter main boom. This powerful crane was chosen specifically for its lifting capacity and versatility in handling extremely heavy loads with precision. The reels lifted during this operation were substantial in size and mass. Each reel had a diameter of 11,400 millimeters, a width of 5,213 millimeters, and weighed approximately 380 tons. The size and weight of these reels required meticulous planning, precision rigging, and the use of a crane with exceptional load handling capabilities like the CC2500-1. Prior to lifting, all engineering assessments were completed, including ground load calculations, crane mat design, and lift path studies. With safety as a top priority, every detail was considered, from wind conditions to crane positioning and load rigging. The CC25001, operated by experienced and highly trained personnel, executed the lift with precise control and coordination. The lifting procedure involved raising the reels vertically, securing them with custom-designed lifting gear, and carefully maneuvering them into their designated positions. The success of the lift was due in large part to the engineering team's preparation and the skill of the operators managing the lift in real time. In conjunction with the lifting operation, the reels and crane components were transported across the site using SPMTs. A fully rigged CC2500-1 crane was moved using a 24-axle Demag SPMT, demonstrating the capability to relocate a massive crane assembly, weighing a total of 514.2 tons without disassembly. This not only saved time, but also reduced risks associated with reassembly and alignment.